This starts at number 5 in your notes packet, something because we've been talking about valence. Um, we've been talking about octet in the valence electrons. Um, we do have some situations where an octet is not going to be how the molecule actually exists. And for example, boron has 3 valence electrons, and boron can be stable with a total of 6. And so what that looks like is that boron is in the center. We have 6 plus 21, which is, sorry, boron doesn't have 6 valence electrons. It has 3 valence electrons. We have 3 plus 21, which is 24 electrons. And the boron is going to be the central atom because there's 1 boron. It's going to put in, right, these 3 valence electrons into bonds. F atoms are going to come and bring valence electrons also. That's 6 out of the 24. And the other 18 are going to go around fluorine. We know that fluorine has the highest electronegativity. So we know that fluorine would never be electron deficient. And this winds up with 6 electrons around the fluorine. I know mine are a little discombobulated there, but if we look, all of the electrons that were from the bond, the boron only winds up with 6 electrons around it, and it is stable. But what we also see is that boron has 3 atoms bonded, 0 lone pairs. So this is trigonal planar. And it has 120-degree bond angles. So it has no net dipole moment. It is symmetrical. BH3 would look very similar, only instead of there being lone pairs around the atom bonded to boron, the hydrogen would have no lone pairs, and it would still be trigonal planar, 120 degrees, no net dipole moment. So that's something that has less than 8 for an octet. We can also have elements or atoms of elements that can exceed the octet. So any element that is in period, try that again. Any element that is in period 3 or lower on the periodic table, so like period 3, period 4, period 5, period 6, okay? Those elements, atoms of those elements have empty d subshells, and those empty d subshells can help to expand the octet. So SF6, we're going to sum up our valence electrons. S has 6 plus F is 7 times 6 plus 48. Nope, that's not the right one. Plus 42 equals a total of 48 electrons. S goes in the middle. S is going to make a bond with each fluorine. That's 2, 4, 6, 8, 10, 12 electrons around the sulfur. 12 from 48 means that we have 36 electrons left. We're going to distribute those around the fluorines so that they have 6 each, right? Giving them their octets. Fluorine is not in at least period 3, so fluorine cannot expand its octet. But now sulfur has 6 atoms bonded, no lone pairs. This is octahedral. And it is symmetrical. All of the dipoles oppose each other perfectly. So there is no net dipole moment. And the bond angles, because this is octahedral, is going to be all 90 degrees. Whereas PCl5, and if we do PCl5, again, we're going to have to take the sum of the valence electrons, which is 5 plus 35, which is 40 electrons. The phosphorus has to be in the center. The phosphorus has to bond at least with one bond with each chlorine. So I'm going to put single bonds in there first. That's 2, 4, 6, 8, 10, which means I have 30 electrons left. Sorry, I was supposed to put minus 10. I have 40 minus 10, which is 30 electrons left. I have 5 chlorines. We evenly distribute, and they get 6 each. Each chlorine gets an octet, and phosphorus exceeds its octet. Now remember, this is 5 atoms bonded, no lone pairs. This is trigonal bipyramidal. And trigonal bipyramidal, what that means is that we basically have a linear through the center of a trigonal planar. So this is symmetrical. This has no net dipole moment. And this, because it is trigonal bipyramidal, because it has the linear and the trigonal planar, we wind up, this is the one with those funky bond angles, where we have the 90, the 120, and the 180 degree bond angle, because of the fact that the 120s comes from the trigonal planar, the 180 comes from the linear that goes through the center, and then the 90 is the adjacent pieces to that. I'm going to say we are actually going to stop there in this video, which ends us with 6 and 7. And I'll probably make another one for 8.